So, very good evening, my dear friends. So, within 3 or 4 days, our CP free online coaching will going to sum up because of you are going to attend PG entrance examination through online CBT, computer-based test. So, in this regard, today's our eminent resource person, Dr. Manjula Madam Garu, Assistant Professor, Department of Botany, one of the prestigious institutions in Twin Cities, that is RBVRR Women's College, Autonomous, Hyderabad. So, Madam, please welcome and start your session, Madam. Please welcome.
Okay, thank you, sir. So today's topic is, small topic, that is anomalous secondary growth in monocots, Drassina. Sir, is it visible? Screen?
Yeah, it is visible, Madam. Please click on slideshow.
Okay. So already we discussed. Good evening. Thank you, sir, for giving this opportunity. So today's topic is, that is anomalous secondary growth. So anomalous secondary growth in monocots. So generally we already know about this anomalous growth. That is, it generally it is not common growth. So it is it occurs what you call so anomalous are abnormal activity. So due to the abnormal activity, so here the growth of the secondary growth occurs due to abnormal activity. So it is called as the anomalous growth. So in many plants, the pattern of secondary growth shows deviation from the normal type. That is generally secondary growth which starts from the cambium. But here cambium which is present in the vascular bundles. But sometimes it may occur from the cambium other than the vascular bundles region, or from the other than the cambium. So here the secondary, if the secondary growth occurs, so it is called as the anomalous or abnormal activity. So the term anomalous secondary growth, which is given for the deviation or variation from the normal secondary growth. So generally it is seen in tropical plants. So reasons for anomalous is secondary growth. So already we discussed about this. That is the normal cambium which behaves abnormally, or normal cambium is situated in the abnormal position. Hence, the tissue cut are placed abnormally. Or normal cambium which does not develop, or if it is present, it is replaced by the additional or accessory cambial rings. So these are the reasons for the anomalous secondary growth. So anomalous secondary thickenings in monocots. So generally secondary growth which is seen in dicots, but here in monocots, the some examples of this monocots which showing the anomalous growth are Drassina, Yucca, Aloe, and Sansevieria and Agave. So secondary growth, it is usually absent in monocots, but since the because here the vascular bundles are closed type, that is closed means that is cambium is absent in monocots, but a very few plants in monocots which show anomalous secondary growth. So examples for anomalous secondary growth in monocots mainly, that is Drassina, Yucca, Aloe, Agave, and Sansevieria. So anomalous secondary thickenings in the Drassina stem. So the primary structure of the Drassina, the young stem, which shows typical monocot stem, that is it contains epidermis, that is the outermost and single layered. Next, it is followed by the hypodermis. Here the hypodermis is sclerenchymatous hypodermis. Next one is vascular bundle, that is closed type. And these are scattered arrangement in the cortex. So here the vascular bundle, they are present in the cortex. So these are the primary structure of the monocot stem, but anomalous secondary thickenings in the Drassina mainly, that is during the secondary growth, which is initiated by the formation of special meristematic zone in the inner cortical region. So here the secondary growth which is occurs by the formation of meristematic tissues in the inner cortical region. So the cells which are present in the cortex region becomes meristematic and act as a cambium. So the multi-layered cambial ring is differentiated from the inner cortical cells that is lying outside the vascular bundles. So the cambial ring which is present outside the vascular bundles. So this cambium is formed in the region of the stem, so which sees its elongation, which stops its elongation, and the shape of the cambial cells also varies here. So here the activity of this cambium is also abnormal. So it cuts a large number of cells to the inner side and few amount of cells to the outer side. So this cambium which produces more amount of cells, more number of cells inside and less number of cells to the outer side. So the cells produced external to the cambium are parenchymatous. So the cells which are produced towards outer side, they are the parenchymatous cells, and the cells which are produced inner to the cambium, they are also partially parenchymatous and partially vascular in nature. So generally in the vascular bundles region, so here the cambium is absent. So the cells which are present in the cortex region, so the cells becomes meristematic and act as a cambium, and it produces more number of cells towards the outside and less number of cells to the inner side. So outer cells are parenchymatous, whereas the inner cells, they are partially parenchymatous and partially vascular in nature. So some are parenchymatous and some are vascular in nature. So the parenchymatous cells which are produced internal to the cambium develop into lignified conjunctive tissues. So the parenchymatous cells which are partially parenchymatous cells, they becomes lignified conjunctive tissue. So conjunctive tissues, they are lignified. The parenchymatous cells becomes lignified and they are called as a conjunctive tissue. So here, the formation of concentric vascular bundles. So the cells of the inner cambial ring participate in the formation of secondary vascular bundles. So usually the secondary vascular bundles which are arise from a single vascular bundle in shell. So the vascular bundle in shell cells which divide by two anticlinal divisions to form a row of 2 or 3 cells, and anticlinal are versus anticlinal division. That is, so here the two divisions, that is anticlinal divisions and periclinal. Anticlinal means that is perpendicular to the cells. They are called as the anticlinal, whereas the periclinal means they are parallel to the cells. These are called as the periclinal division. So all these cells then undergo periclinal divisions to form a peripheral cells. So later divisions are irregular and to form a mass of cells. So here, formation of concentric vascular bundles. So here, the divisions, these divisions, they are called as the anticlinal divisions. So whereas these divisions, they are called as the periclinal divisions. So periclinal division, they are parallel to these cells. Whereas anticlinal division, these are perpendicular to these cells. So here the centrally placed cell metamorphosis into the phloem cells, whereas the peripheral cells, they are differentiated into xylem elements. So thus the individual secondary vascular bundles which consist of a centrally placed phloem, so which is surrounded by the xylem, that is concentric vascular bundles, that is amphiβasal. Amphiβasal means in the central phloem which is surrounded by the xylem. So this is called as the amphiβasal cells. So the cambium then cut off parenchymatous cells. So the newly formed parenchyma cells, the newly formed parenchymatous cell pushed the vascular bundles toward the central region. So after some time, this cambium again behave abnormally to produce the another vascular ring of vascular bundles. So this time the portion of the vascular bundle again changes and this process will continues, and from this, so the cells again this process will continue and many rings of concentrically arranged vascular bundles are formed. So the last ring of vascular bundles are embedded in the mass of lignified conjunctive tissue. So the cork cambium may also develop, and this cork cambium produce the bark outside. So here, this is the Drassina stem. So these are the vascular bundles. So here epidermis, outer layer, and it is followed. So during the secondary growth, this spellum, cork and cork cambium. So these are the cortex region. So here from the cortex region only, here the cambium, the outer cell, the cortical cells, they behave meristematically and they produce the cambium. So here, the production of this amphivasal vascular bundle. The central one is the phloem and outer one is the xylem. So in between these are the conjunctive tissue. So these are the secondary parenchyma. So this cambium which producing secondary parenchyma towards more number of secondary parenchyma towards outside and less number of secondary parenchyma towards inner side. So these here, the some are partially parenchymatous and remaining behave as a vascular cambium. So here it producing this vascular cambium which producing the vascular bundles, whereas the remaining this partial parenchyma, this becomes lignified and they are called as the conjunctive tissues. Like this process will continue. So many amphivasal vascular bundles are present. So this is about the anomalous secondary growth in Drassina.
Okay, madam. Shall we sum up today's class?
Yes, sir.
Okay. So Drassina, anomalous secondary growth in Drassina is clearly explained by Dr. P. Manjula Madam Garu. Really nice talk about the anomalous secondary growth due to the cambial activity in the Drassina, and also some of the other monocots anomalous secondary growth is there. Madam will continue tomorrow class. Okay, we'll stop today, my dear friends. Thank you very much, madam. So we will meet next class.
Okay, thank you, sir.
Right.